Move on to the back, which is very graph heavy. We've already done a bunch of graphs, we're going to hit some more. So make sure you have a calculator handy if you have one, or maybe your tablet may have an app on it you can use. Okay, so first thing you see on the back of the first page of your final is your polynomial function. What a polynomial is, it's a bunch of algebra pieces added or subtracted together that all have whole numbers for their exponents. So the best thing to do, guys, is to use the calculator to graph it. So I clear out the old stuff, get my calculator out, and type in the function they gave me. So for the example in the notes, it's 2x to the third. Make sure you use your arrow key to get out of the exponent to type the next part, minus 3x squared minus 3x plus 2. And then it's time to hit graph. So when I hit graph, I'm going to see my basic curve. Okay, the image I gave you in the notes is from a website, so it zoomed in for me. Your general calculator is going to look like this. Okay. So what I'm going to do now is just kind of sketch it on, and I did give you graph paper on your review, so you can sketch it yourself. But it looks something like that. Okay, so I have the graph, and then they're going to ask me to do a bunch of stuff with it. Okay, they're going to ask me to do the intercepts, find the max and min points, and the domain and the range. So again, you can do them by hand if you want to, but your x and y intercepts are going to go super fast with the calculator. And since this exponent is a 3, the calculator is going to be your best bet because the quadratic formula won't work and it doesn't necessarily factor. Okay? So what I'm going to do is I'm going to go to second trace and select the 0 option and get my x-intercepts. Alright, so I move my blinking cursor to the left. I've got a bunch of them, so I'm going to have to do this a bunch of times. I go to the right, I hit enter. Alright, first x-intercept is at -1, 0. Alright, so I've got another one in the middle and another one on the right. So second trace, 0. Going towards the x-intercept in the middle, go to the left side, hit enter. Right side, hit enter. For the guess, get as close as you can. Alright, so I get 0.5, 0, so it's at half. Last one, second trace, 0. Move your blinking X. Left side, right side. Get as close as you can for the guess, and bam, I've got 2. Alright, whew. Lots of second trace on that one. For the y-intercept, this one's a little easier. I can do it by hand or with the calculator. If you use the trace feature, you want to go towards where x is 0. So 0 is x and y will be 2. Okay? The other way you can do it is plug 0 in for x or just look at the constant term. The y-intercept is always the last part of your equation. Alright. There are max and min points on this graph. Second trace will find them for you. So I'm going to hit second trace. I'm going to select minimum or maximum, doesn't matter which one I do first. I'm just going to go for the minimum because that's what I feel like doing. And so again, move your blinking X to the left of your minimum point, blinking X to the right of your minimum point, and then ask it to get its exact answer. Okay. So the minimum point is the bottom of that hill, guys. So I got a decimal, I got 1.366. and -2.598. For the maximum point, we're going to do the same steps. And again, hit pause if you need to. You need to practice this with the calculator. So if need be, hit pause and try it yourself and check your answers with mine. Second trace, maximum. Move your blinking X to the left, hit enter. Blinking X to the right, hit enter. Get as close as you can for the guess. Alright, another decimal. This one is -0.366 for x and 2.598 for y. a lot of times, guys, you will see a little bit of repeated numbers, and that's okay. That just refers to the fact that there's a little bit of symmetry in the graph, okay? Okay, domain and range. So, we've talked about this before. If you forget which one is which, think of that wrapper that's been around for a long time. I call them an old wrapper. DMX, x-axis, range is the y. So what you're looking for is, does the graph go off the screen? So you can look at your sketch or you can look at your calculator. Yes, it does. Does it go off on the left? Yes. Does it go off on the right? Yes. Is it all connected in the middle? Yes. That means your domain is all real numbers, x, e, r. All right. For the range, same thing. Y-axis goes up and down. So you ask yourself the questions. Do I go down off the screen? Yes. Do I go up off the screen? Yes. Am I all connected? Yes. And so your range is all reals as well. Okay. Then we get to the part that we didn't practice as much. This is something that you do a lot of in calculus, but it makes a lot more sense in calculus, which is why we didn't do a lot of it this year. They're asking you to tell when are you increasing and when are you decreasing. So when you do that, I know you guys know what increase and decrease means. Increase should go up, decrease should go down. You need to read your graph from left to right, just as if you're reading a word. When I read the word increasing, I start with the I and I end with the G. When we do this, guys, we're going to focus on the x-axis, okay? So, am I increasing? On this example, for sure. I increase all the way until I get to here. This part right here is increasing. Then, between the max and the minimum, I decrease, and then again, after I increase. So, how do I explain that? Well, you explain it using the x-axis. So, you're going to go from negative infinity until you get to that max point. Well, the max point has an x value of negative 0.366. All right? We said we increase again after the minimum point, so the minimum point has an x value of 1.366, and then we increase the rest of the time, so until positive infinity. Decreasing is going to, again, we're using the x-axis, happens in between my max and my min. So my minimum point is on the left, the max is on the right. We go left to right, just like we read. So the minimum point and maximum point are right up here. So for the max, it's going to be negative 0.366 to the minimum, which is 1.366. Okay. Last part, and I'm actually going to do this on a piece of notebook paper so that you guys have a nice, clear, clean slate. So take a look, hit pause if you need to write stuff down, or back it up if you want to hear something again. I did a lot of stuff with the calculator and the trace feature to get this information up here. For the domain and range, I had to kind of use what I know about domain and range and the fact that the graph is all connected and goes on forever. All right, so the last thing that it asks you about is called average rate of change. A rate of change, guys, is a slope. So they're actually asking you to go back to your knowledge on slope and do your old school formula, y2 minus y1 over x2 minus x1. So, that being said, I need to know what my numbers are. They give me two numbers. Now, let me read them off the problem. It says, determine the average rate of change from 2 to 5. So, I have 2 and I have 5. Well, is 2x, is 2y, what is the deal? Well, they are usually going to describe this using your x values, okay? So x is going to be 2 and x is going to be 5. That means x1 is 2 and x2 is 5. To find the y values, I have to plug them into the function. So I'm going to take the 2 and the 5 and put them into the function I was given, the f of x. So for me, my f of x is 2x to the third minus 3x squared minus 3x plus 2. All right. If you need help, use your calculator. So 2 times 2 to the third minus 3 times 2 squared minus 3 times 2 plus 2. Alrighty. That's 16 minus 12 minus 6 plus 2. There was a typo in this one also, guys. The answer should have been 0. So the first point that I'm going to use, my x1, y1, will be 2, 0. For my y2, I need to plug in the 5 because it said average range from 2 to 5. So 5 goes wherever there's an x in my f of x. 2 times 5 to the third minus 3 times 5 squared minus 3 times 5 plus 2. Okay, again, use your calculator if you don't feel like doing it yourself. This is going to be 250 minus 75 minus 15 plus 2. Okay, starting to run out of brain cells, so I'm going to use the calculator myself. 250 minus 75 minus 15 plus 2 is 162. So x is 5, y is 162. And now I can do my slope formula. 162 minus 2 over 5 minus 2. Kind of out of space, so I'm going to come down here. So for my slope, which is the same thing as the average rate of change, it's going to be 160 over, or no, excuse me, it's 160 minus 0, excuse me, that y value is 0. So that's going to be 162 over 3, and that is actually divisible, guys. I'm going to use the calculator to check myself, but I'm pretty sure it divides evenly. It does. My answer is 54.